Hello, this is the continuation of the diffusion problem that we had shown before. So this is a diffusion equation that we are now going to solve by using a different type of geometry here. So here we have two domains, domain 1 and domain 2, which are connected through the interface. So we're going to set it up in CKFluidSoft and then run it and display the result. So we are going to draw the geometry here. Let's do a quick drawing. So we draw this geometry that we want to use. Then we have to draw the next one. Let's introduce 2 points. 1 point here, 1 point there. Then we introduce the four sides. Let's put one line here, one line there, and one line there. We connect them. We will resize them later. We combine the points, combine them, combine the points, combine them. So this is the geometry that we have. Now we have to make this one to be a contour, a complete contour. Let's click there, select the four sides. Then we have the next, the other geometry. So we have domain 2 and domain 1. So these are the two domains. So by default, there are some default equations inside. We are going to update them. So here we see two domains, each one with the equations. So we remove the second equation. We're dealing only with one one uh, one one component into the array. So we remove the first one, we change that, we also remove this. So the domain parameters are here, and then here we have the equations, specific data. What is this? Hello to everyone over there. This is Sami Mukadi, and I'm going to present to you the software called CKFluidSoft. CKFluidSoft is a user-friendly tool that has been designed for use by scientists and engineers. It is a CFD modeling and simulation package, as well as a differential and algebraic equations solver. What's the motivation behind that is this. Scientists and engineers, they often face the task of making optimal choices and decisions related to some chemical or physical processes. Then they have to frequently perform a lot of calculations through modeling and simulations to guide the decision making. So the process of modeling and simulation requires the solution of differential and algebraic equations. Basically speaking, any chemical or physical phenomena that scientists and engineers deal with can be described as a set of differential and algebraic equations. Those phenomena may include anything from the fluid flow, fluid mechanics. They may include mass transfer, convection and diffusion included. They may include heat transfer, convection and conduction included. And they may include the chemistry, which is chemical species and reactions among those species included. It could also be from electricity, which would include the transfer of electrons, the production of electric power, and the magnetic field, and even more than that. So the CKFluidSoft has been designed to provide a very efficient way to set up those kind of equations, to solve them, and then to produce the numerical and graphical results in a much more user-friendly way. So besides that, CK-Fluidsoft also includes some predefined models for a certain number of industrial processes, such as plug flow reactors, fixed bed reactor, fluidized bed reactors, catalytic converter, diesel particulate filter, parallel plates, and more than that. As we said, CK-Fluidsoft is also a differential and algebraic equation solver. So we're going to show the main steps involved in using it either as a CFD package or a differential and algebraic equations solver. So there are five main steps involved in that. The first step involves the creation of the geometry. So one need to draw the geometry, the domain of interest. And then the second step will then involve the description or the setup of the equations to be solved. Those equations can be imported for predefined models, or one may define his own equation, which could be anything or just a representation of chemical and physical processes taking place within that geometry. Then one would also need to set up the boundary conditions, provide the initial conditions if we're dealing with a transient case, or one would need to provide also initial guess in this case if we deal with the steady state case. And then in that, one would need to provide, to define the parameters. The parameters could be anything, any number or any valid math expression that one may think of. The package also includes a chemistry package that one may use to define chemistry. This package is very effective for introducing the chemistry within the CK-Fluidsoft. And after that, one may update the numerical tolerances and the numerical methods to be used during the solution process. After that, we click on compile and solve, which will be then a step where there will be a discretization of the domain and then the calculation through numerical differentiation and numerical integration. So finally, we display the result in numerical form and in graphical form. So these are the main five steps that are included when one uses the CK-Fluidsoft. So we thank you for your interest in using CK-Fluidsoft. We wish you good luck and we'll be glad to get some feedback from you. Bye and take care.